Hello and welcome back, guys. So, today we will be doing some mega questions that will involve all these three concepts of binomials, partial fractions, and logarithms. Okay, so let's begin. This question, I can see that. Let's read the question. Show that when x is sufficiently small for x power 3 and higher powers to be neglected. Whenever this comes, you know that it's a binomial question. Okay, and I can see that this is not in binomial form, this is in partial fractions form. Okay, so first of all I will convert it into partial fractions, and then I will solve for independent terms for binomials. Okay, so let's begin. This is an interesting question. Stay with me so you'll understand. Okay, 3 plus x over 1 minus x square. So we have a whole square in the denominator, but at the same time this whole square can be factorized, right? 1 minus x, 1 plus x, because this is a difference of two squares. Okay, now what do? We just do it a over no, we just write it as it is. Okay, over here is equal to a over 3 plus x plus b over 1 minus x plus c over 1 plus x, all the standard procedures. And then we move on to the second step. Now it's getting boring actually, because we're doing the same thing again and again and again and again. We know now you need to tell me the second step. What is the second step? I'll pause for 2 seconds and you will write it in your comments in the comment section. Okay, 1 and 2. Okay, so now what do? We destroy the denominator. Okay, so we do we remove all this denominator over this side. Okay, so when a multiplies by this entire thing, the 3 plus x cancels out, and I have 1 minus x and 1 plus x. Okay, so a into 1 minus x and 1 plus x can be written as 1 minus x square. Okay, that is fair. 1 minus x square plus b into 1 minus x cancels out, so 1 plus x and 3 plus x, and then we have c, which would be 1 minus x and 3 plus x. Okay, now we have to solve for a. What do? These news okay, finally. So what do we do now? What is happening? Yeah, perfect. Okay, so over here now we have this form. Now what do? We solve for a, then for b, then for c. For solving for a, what do? You have to tell me now. We put this is equal to 0. The denominator of a in the previous step, 3 plus x would be equal to 0, x would be equal to minus 3. 12 would be equal to a into 1 minus 3 square, which would be positive 9. Okay, 1 minus 9 is minus 8. So that means that a would be equal to 12 over minus 8, which is minus 12 over 8, which is, if we divide this entire thing by 4, it would be 2 and 3. This means that it would be minus 3 over 2. Okay, then we solve for b. Okay, and what do? 1 minus x equals 0, x equals to 1, and now 12 is equal to this entire thing, 1 plus 1, 2 times 4, 8p. Okay, interesting, because this is coming similar answer, 12 over 8, which is 3 over 2, but positive this time. Okay, and now for c. Now what do for c? We put 1 plus x equals 0, and x would be equal to minus 1, and 12 would be equal to 1 minus x, which means 1 minus 1, 1 plus 1, 2. 2 times 3 minus 1 is 2 times c, which means 4c. 12 over 4c equals to 3. Okay, that is our answer. Now what do? This is not our answer for the question. We need to go on to the binomial part as well. Okay, so for the partial fraction, what is the answer? Minus 3 over 2. I'll just write it over here. minus 3 over 2, 3 over 2 and 3. Okay, fine. 3 over 2, 3 over 2, minus 3 over 2, and then we have positive 3. Okay, now what do? We solve this binomial expansion. Okay, and we need to get this as answer. So we do not solve this for the entire thing, because as I discussed, these are infinite values, because when this denominator would come in the numerator, the power would be negative, right? That would be an infinite expansion. We were not doing the entire thing. We're only doing for sufficient small for x cubed and higher powers neglected. So we are doing till x squared, and if we see this answer, it is also till the x squared term. Okay, so let me just do it over here. Let me just erase this entire thing, that I can do it underneath. That would be much easier for me. Okay, perfect. Now what do? We need to basically expand all these, right? So it is minus 3 over 2, and then we have a 3 plus x power minus 1. Then next up we have plus 3 over 2 to 1 minus x power minus 1. We have 3 into 1 plus x whole power minus 1. Okay, now what do? We make first of all this as 1. Okay, then that would be make the expansion possible. So how do we make it 1? We'll now from now on we'll just do these terms independently. Okay, so what if we do is that minus 3 over 2 is outside, then we have a larger bracket, then we take 3 common. Okay, and then we would have 1 plus x over 3. Okay, then we would have a whole power minus 1. Okay, next up what we will be end up getting would be 3 power minus 1, which means 1 over 3 times 1 over 3, 1 plus x over 3 minus 1, and minus this would cancel out. Okay, it would be minus 1 over 2. Okay, is equal to minus 1 over 2, 1 plus x over 3 minus 1. Okay, now we can just expand this independently, and then we would multiply it by minus 1 over 2. We just need to remember that there is this minus 1 over 2 over here. Okay, so what we can do, or we can just do it from here onwards, as we follow the standard procedure of minus 1 over 2 here, and now we do the expansion in this larger bracket. Okay, first of all it would be 1, and it would be minus 1 times x over 3. Okay, and the next step it would be minus 1 times minus 2 over 2 factorial, which is 2, and we would have x over 3 whole squared. Okay, so this is our expansion. We need to only read the up till the square term. Okay, now we will multiply it out this bracket, minus 1 over 2, or first of all we can just simplify the internal things. Minus x over 3, it will be positive 2 over 2, which is 1, so x square over 9 plus x square over 9. Okay, and it would be minus 1 over 2 plus x over 6 minus x square over 18. Okay, so this is our expansion from this part. Now let's move on to the other parts. Okay, this is 3 over 2x. Okay, we'll just add a plus over here, just do 3 over 2 and the curly brackets, 1 minus x. This is already 1. Okay, so we don't need to make the coefficient like the first term as 1. We already have it as 1. So what will we do next? We will expand. Okay, so 1 comes as it is, then we would have a minus 1 minus 1 times a minus x. Then we would have a plus. After that we will have minus 1 times minus 2, which means positive 2 over 2, which means positive 1. So it would be x square simplified. Okay, and what will we have is, we'll add a plus over here, 3 over 2 plus 3 over 2x plus 3 over 2 x square. And for this term we still have this over here as it is, the first term as 1. Okay, so we just do 3 and we expand, and it would be 1 plus minus 1 times positive x this time, and the next term would be positive 1 over x plus x square. Okay, so that is like it for this expansion. Then we would just multiply it out, 3 plus 3x plus 3x square. Okay, so that is our entire expansion. Basically, if we sum it up, it is, if we add it over here, it would be 3 over 2 plus 3 over 2x plus 3 over 2x square plus 3x plus 3 plus 3x plus 3x square. Okay, so that is our entire expansion. Now we need to group similar terms together. But how do we do that? We take minus 1 over 2, then we have this next constant 3 over 2, and then we have 3. We add these all together, which means minus 0.5 plus 1.5, which is actually 1. Then we have a 4. Okay, we would have a positive 4. Then we would have an x plus 6. Then now we do the x power 1 terms, x plus x over 6. Then we have 3 over 2. Then we have 3. Okay, so x over 6 plus 3 over 2 plus x plus 3. Okay, 3x obviously. Okay, now if we remove the x, because we just dealing with common terms, we just need the plus over here. Okay, now I can take LCM. If we multiply this by 3, then it would be 1 plus 3 times 3 is 9 over 6 plus 3 be 10 over 6 plus 18 over 6, which means 28 over 6. You can simplify it to be 14 over 3. Okay, so we would have a 14 over 3 as over here, 14 over 3 x. For x squared terms, what we will do is minus x square over 2 plus 3 over 2x square plus 3x square. Okay, so how do we do that? Minus 1 over the same, we'll do it in rough working. It depends if it is in a paper 1 question or paper 2 question. In paper 1, calculators is not allowed, but in paper 2, calculator is allowed. Okay, now in x square term, minus 1 over 18, we would have plus 3 over 2, and we would have a plus 3. Okay, how would we do that? We'll just multiply it by 9, this thing by 9. Okay, so 3 by 9 is 27. 27 minus 1 is 26. 26 over 18 plus 3. Okay, now we'll multiply 3 by 18. What is 3 times 18? Okay, I don't have a calculator with me, guys. Bear with me, please. 8 times 3 is 4, 2, 24. 3 times 1 is 3 plus 2, 5, 54. Okay, 54 plus 26. 26 plus 0, 1, and that would be 80. Okay, it would be 80 over 18. If we simplify it, would be 40 over 9. Okay, so what do we end up getting? 40 over 9 x square plus 40 over 9 x square. This is our expanded answer. Let's just compare it. Okay, and if it is right, which 20 over 3 and 88 over 9. Okay, 20 over 3 and 88 over 9. Okay, the denominators are right, the numerators are messing up. The 4 is correct though. Okay, so I must have made a mistake in the adding over here. Let me just bring a calculator and we'll do it manually. Let me see. 1 over 6 plus 3 over 2. 1 over 6 plus 1 over 6 plus 1.5 plus 3. That is 4.67. And my answer is, that means like 4 wholes and 2 over 3, which means 4 times 3, 12 plus 14 over 3. Yeah, that is 14 over 3. What is the answer? It is 20 over 3. Oh, interesting. I must have made some mistake over here. Guys, you could figure it out on your own, right? I'm too tired to do that. I'm too lazy to do that. Yeah. Let's move on to the next question. Yeah. Okay, so this is the next question that we have. Okay, so this is a logarithmic question. Let's just see. Given that log of n to the base a is equal to this entire thing, okay, find the value of n, find also the value of log, blah blah blah. Okay, first let's do the first part, find the value of n. Okay, so log of n to the base a is equal to this entire thing. Okay, how do we do this question? First of all, what I can see is the common base over here, the common base of a. Okay, and this is also a. So what do we do is we make it a single base. Log of n to the base a would be equal to 1 over 2 log of 1 over 2 log of 24 over 0.375 over 3 power 6. Okay, first we will divide this, then we would divide that by, or I just write it over here, 3 power 6, and that is to the base a. Okay, now what do we do is that we simply divide it. 24 divided by 0.375, which is 64, and we have to divide it by 3 power 6. Okay, so we divided by 3 power 6. Okay, 64 over 3 power 6. And what is 3 power 6? First we need to see that. 3 power 6 is 729. 64 over 729. Yeah. 1 over 2 is equal to 1 over 2 times log of 64 over 729 to the base a. Okay, and that is equal to log of n to the base a. Okay, now what we can do is log of n to the base a is equal to log of 64 over 729 whole power 1 over 2 to the base a. Okay, now I know the 64 is a whole square, that would be converted into 8. Let's just see if 729 is as well. Okay, so if we do that, yes, it is 27 is its square number. Okay, what we can do is log of n to the base a would be equal to log of 8 to the base 8 over 27 to the base a. Okay, so now I can see that log a and log a on both sides could be cancelled out. That means that n would be equal to 8 over 27. Okay, that is easy stuff. Now what is this? Find the value of log of n to the base a when a equals 2 over 3. Okay, now that we know that a equals 2 over 3. Okay, now that we know that n is equal to, what is n equal to? 8 over 27, right? Log of, and now if a would be equal to 2 over 3, 2 over 3, 8 over 27 to the base 2 over 3. Yeah, this is like the entire thing, entire crux of it. Okay, oh, this is an interesting pen. Let's just make it thicker. Interesting. Okay, fine. Yeah, so what do we do over here is that I am processing right now. Yeah, we need to calculate this value basically, right? So how do we do that? What if we change the base? I don't actually know. I'm like experimenting with you as well. So if we change the base, that would mean that we can make the base as 10. Okay, so if we make the base as 10, that would mean lg 8 over 27 over lg 2 over 3. Interesting. Oh, okay, so now what if we do it like 8 minus lg 27 over lg2 minus lg3? No, that doesn't appeal, you know, that is not very appealing. Okay, never mind. Let me just do it with a calculator. Like, you can do it on your calculators, but what is the basic concept of log? If we revise the basic concept of log, that log of, let's say, 100 to the base 10, what would be the answer? It would be 2. Why? Because 10 power 2 is equal to 100, right? So what does that mean? If this is equal to x, okay, so that means that 2 over 3 power x would be equal to 8 over 27. Okay, so if we make it in 2 over 3 form, if we make this into this form, what do we get? 2 over 3 whole power x would be equal to 2 over 3 whole cubed, because if we cube 2 we get 8, if we cube 3 we get 27. Okay, the cube is right. So what is x? X would be 3. So this is the answer. Log of a n would be equal to 3. Okay, so that is it for the two questions. I hope you would enjoy it and learn something. Okay, bye bye.